When I first started playing craps, I really didn't know what to expect. I knew some of the mathematics behind it. For example, I knew that the house edge on the pass line was 1.41%. So I got really into this because it's such a complex game with all kinds of different betting strategies, bets, and the dice outcomes, and all of that kind of stuff. What I decided to do is start writing some simulations to see what might happen under different scenarios and under different strategies. And for this simulation, we're going to play a pass line at a $15 minimum table, which seems to be normal minimum that you're going to find nowadays. And then we'll take double odds. And we're going to play for 10 shooters. And I'll simulate 1,000 different sessions of this, and we'll take a look at the outcome. Anytime you're doing a simulation, it's always good to talk about your objectives up front. And I really had three main objectives. The first one, I just want to know what are the chances that a session is going to win money or lose money. Now, the second one, which frankly starts to get a little more interesting, is how much is a player likely to win or lose over a session? And third one is how much are we actually wagering using this strategy? Now, even beyond that, there's a few other things that I'm curious about the kind of gameplay, right? So, given the strategy, how many rolls are you expected to roll over the 10 shooters? How many points might you hit? How many naturals, 7 or 11 on a come out? How often does that happen? And how many craps? How often does that happen? With that, let's get into it and let's run the simulation. Okay, so here let's pull up the overall simulation statistics. And again, I like to kind of see this stuff from a high level so that I just understand and make sure that the simulation is working correctly. So we had 1,000 sessions. That's what we input and what I expected. 10,000 shooters, also what I expected because each session has 10 shooters. 85,519 rolls. This is going to average to 8.6. Now, the mathematical average, according to the Wizard of Odds, is 8.5%. So we're right on track. I also like to kind of look at the amounts that are won and lost and calculate the house edge of this simulation. Now, the total amount bet, so all the amount, total amount over the simulation, the 1,000 sessions, everything that was put down on the table, 888,180. The total amount won was 490,000 and lost 492,000. So our net win and loss is 2,472. Now, what that means is the players in total lost $2,472, and essentially that's what the casino made. Now that equates to a house edge of 0.278%, which is low. It's lower than even the theoretical amount, which is 0.606, and that just goes to show you this game is random. Any individual sessions or even 1,000 sessions are not going to follow the mathematics precisely, and there's always going to be some randomness, and you never know what's going to happen. So let's get into the analysis. So first question: how likely is it that a player is going to win or lose any amount of money over the session? 54.3% of the time the player ends down. A little less than 1% they're neutral, which means they didn't win or lose any amount of money. Almost 45% of the time the players are up, so they won $1 or more. So again, what's the theme here? You're more likely to lose than win on this game in the casino with this strategy. Now, the second question really is where I think it starts to get a little more interesting, right? How much is a player likely to win or lose over the session? And what are those limits of the win or loss? So let's take a look at this chart. So if you look at the x-axis, that's the amount won or lost. And the y-axis is the number of sessions that won or lost that amount. That's 171 sessions that won or lost between $0 and $100. And if you look over here, the maximum amount won is between $800 and $900. The maximum amount lost, which is 7 different sessions, is between $400 and $500. So if you look at the kind of shape of this distribution, it's definitely a little bit lopsided. More people are losing, but they're losing smaller amounts. Very few people are winning, but when they win, they're winning more than the losers lost. So that's, I think, one of the reasons that the game gets interesting, right? Because you have this kind of lopsided distribution, and those wins are like really great wins. The losses are there and ever present and frequent, but they're not as painful as the joy of getting those wins. And I think that's what kind of gets people really into this game, and what makes the game pretty exciting. This is another way of looking at the same data. This is a box plot. On the x-axis, we have the amount won or lost. This bar right here in the middle, this is the median. And the median here is negative $21. And that means that half the sessions ended with a loss greater than $21. Half the sessions ended with a loss of less than $21. The box here is the middle 50% of the sessions. 50% of the sessions were between a win of about of $126 and a loss of $151. Then you have whiskers. You can see that the lower whisker is $465 loss. The upper whisker is $541 loss. And then on the upside, you have even some outliers, very rare outcomes, but they're there. And the absolute maximum amount won during this simulation was $879. That's basically the tendency of what you'd expect. Winning as much as $879 or losing up to $465. Now, number 3, how much is wagered per session and per shooter? So here the median is $870. We can also look at what's wagered per shooter. And if you look at this one, the minimum is $45, and that's just the nature of this strategy, right? It's $15 pass line, $30 in odds. For every shooter, you're going to do that at least once before you 7 out. But the median is $60, and that's because sometimes you get a point, sometimes you have a couple craps or a couple naturals, so you're putting down more and more money, and that's where that median comes from. Other stuff that's super interesting is what's the gameplay look like? How many different roles are you playing? So I'll pull up the table here. So this is number of roles. You can see median for this session is 84, and for the actual shooter is 7. And how many points? So 7 points is the median. 3 points per shooter. The naturals, 5 naturals over the session is our median, and maximum was 21, which is pretty intense. 22 points and 21 points. Those are pretty interesting rolls. We'll have to take a look at that in another video. Anyway, I thought those numbers were interesting. They're a little bit lower than I expected. I thought that there would probably be a little more naturals and caps. I'm going to do this quickly because I don't want to spend a whole lot more time on the video, but this is a single session results, and I just wanted to walk you through it so you could kind of see what the data is behind all of these statistics. So this is session 875. This chart shows the amount won or lost by roll, and you can see that first shooter just did great. They won hundreds of dollars. Here's the analysis. So they did 90 rolls. They had 7 come out wins, which is naturals, 4 come out losses, which is craps, 19 different points set, 41 what I'm calling points pushes. This is basically when you roll, but it doesn't resolve the point. And then 9 points are made. I'll just kind of run through this example. Shooter 1 is the most interesting for this particular one. So we had the first roll. We put down a $15 pass line bet. We got set a point of 5. We put $30 on the odds. We roll 6, 3, and then 5. We got paid out. Since the odds on the 5, it's going to pay 3 to 2. So that's $45, $60 total win on that one. Then we set a point of 8, put down our odds. a bunch of rolls and hit the 8. 8 pays 6 to 5, so that's $36 plus the 15, $51. 12 craps, so we lost our Passline bet there and made another one on the 14th roll. Set a point of 9 and hit it. Then had craps again. We hit a couple 11s and then set a point of 4 and hit that after just a couple rolls. That pays 2 to 1, so that's essentially why it's $60. So they won $75 on this one. They hit a 7, won $15, then set a point of 6, 7 out on that one. So $216 they ended up with cumulatively over this shooter. 27 rolls. Great shooter, huh? So they bet $300 and 27 rolls for a win of 216. And I'm just going to scroll through some of these other ones. Here they didn't win anything. They 7'd out. Shooter 3, they hit a point of 4, which is nice. And then 7'd out for a whole bunch of rolls. They said a second point of 4. So they said a 4 and then another 4 and then 7'd out. On shooter number 4, they hit a point of 8. They hit their first point and missed their second one. Shooter number 5, they hit the 7 on the come out roll. So they won the $15 and then had a 0.7 out right after that. So, lost them 45. So $30 was the cumulative loss on this shooter. So their average bet per shooter halfway through is $117. Shooter 6 is a 0.7 out. Shooter 7, they had a craps. They hit their point of 6 after a few rolls and then hit another 6 and then hit a 7. So they won some money off this one. 15 rolls. That's pretty decent shooter. Shooter 8 is a 0.7 out. And shooter 9 hits natural, hits craps, hits a point, and then 7's out. So they won $15 there. And shooter 10, they hit the 11 and then set a point of 6 and 7'd out. So at the end of it, they bet $1,020, 102 average bet per shooter, 90 rolls, and a total win of 129. So if I was playing that, I'd probably look for a little more action than that, but they did pretty well for that session. So $129, so not too bad. Now that's what I have for you today. This is the video. I hope you found this interesting because I'd really like to talk about math and statistics and the simulations and how all that works. So if you have any ideas or strategies you'd like me to simulate, I'm all ears. Leave a note in the comments. Thanks for watching and take care of yourself. Good luck out there.